All right, guys. First today we are going to go over your entrance ticket. So this was review from last time. So the first one was using that exterior angle theorem, or with the remote interior angles, that says that the two remote interior angles are equal to the exterior angle added together. So that's where this first equation came from. Solve for x and you get 12. All right, so for the next problem, given that two sides of the triangle are 9 and 12, what is the range of possible values for the third side? So your inequality should read 3 is less than x is less than 21. Remember, a good way to think about that is to consider what if 9 and 12 are the smaller sides? So if 9 and 12 are the smaller sides, that means 9 plus 12 has to be greater than the third side, in which case 21 has to be greater than x. That's where the 21 is greater than x comes from. But the other case is what if 12 is actually the largest? That means that 9 plus x has to be greater than 12, if 12 is the largest side. So we subtract 9 from each side, and x is greater than 3. So that's where the x is greater than 3 comes from. Considering your two options, what if 12 is the largest? What if x is the largest? All right, so this next one, first you need to find that missing angle, h, from all the angles adding up to 180. And then the shortest side is across from the shortest angle or smallest angle, longest side across from the largest angle. So the shortest side is GF because that's directly across from your smallest angle. Your largest side would be GH because that's directly across from your largest angle. All right, so real quick, go ahead. Oh, actually, sorry, one more. So this one lists the angles of the triangle in order from smallest to largest. So same thing on this one, just going backwards. So the smallest angle is going to be across from the smallest side. Largest angle is going to be across from the largest side. All right, go ahead and write your name at the top of this paper. Give yourself a score from 1 to 5, 5 being I didn't need help from anybody else. I didn't ask a single question. I knew what to do and I got them right. If you had to use somebody else's brain to help you out, you're maybe like a 3 or something like that. So anyways, give yourself a score from 1 to 5. Stack them in the middle of your table. Your substitute is going to come pick those up and pass out notes. And we'll do some notes together. So pause the video until you're ready for notes and then you can unpause. All right, so on our notes, we have a couple of topics today. First topic is the base angle theorem. So base angle theorem has to do with isosceles triangles. So remember, isosceles triangles are the triangles that have two sides that are the same. And we have some special vocabulary for isosceles triangles. This is called the base. It's called the base because it's the side that's not congruent to any other side. The sides that are congruent to each other are the legs. So we have two legs. The angle that's in between your two legs is your vertex angle. And then your other angles, whoops, here and here, those are your base angles because they are attached to the base. And so we have these two awesome theorems that when I get back, we'll be adding them to your purple proof toolkit sheet at some point, so you can go ahead and bring that to class next time. But the base angle theorem says that if two sides of a triangle are congruent, so like if we know this much about a triangle, that they're congruent, then we automatically know that the base angles are also congruent. The base angle converse theorem goes the other way because it's the converse. So the converse theorem says, hey, if we know that two angles are congruent in the triangle, then the sides across from those angles have to also be congruent as well. So base angle theorem goes from we know something about the sides to helping us know about the angles. And the converse starts with, hey, we know something about the angles, and that helps us know something about the sides of the triangle. So for example, if we're solving for A and B in these triangles using the base angle theorem, the first thing I notice is that in this triangle here on the left, we have two congruent sides, one here and one here, which means that the angles across from those sides are going to be congruent. So that B angle is congruent to this angle. And now we'll just do a little math. So all triangles have 180 degrees. We've already used 60, so how many do we have left for that same triangle? 120. So we have 120 degrees left for that triangle, and two angles are going to split it equally. So 60 degrees. So B is 60 degrees. So we've got 60 here and 60 here. All right, there definitely are a couple of ways that we could solve for A, but if you're using the base angle theorem, we can say, well, since we have these congruent sides, the angles opposite of these sides are going to be congruent. So if that blue one is 30, this blue one is 30, which means that we have used 60 total degrees in that triangle. So 180 minus 60 means that I have 120 degrees left for A. You also could have solved for A because if we know this guy is 60, then the 60 and the A form a linear pair because their bottoms make a line and they share a side, and linear pairs are also 180. So you can use those rules that we learned back in the day too. All right, so here's another example. Solve for the value of X and the length of segment RQ. The segment's supposed to be up here. So the length of segment RQ. All right, so in this picture we have congruent angles that are marked, which means that the sides across from these angles are congruent. So RP is congruent to RQ. And if they're congruent, that means that they're equal. So x squared minus 8x equals 3x minus 10. Whenever you see an x squared and an x, you're going to have to factor. So before you factor, bring everything over to one side so that you have an equal 0. So x squared minus 8x minus 3x plus 10 equals 0. I'm just going to combine my like terms to get x squared minus 11x plus 10 equals 0. And now we're going to factor. We're looking for two things that add to negative 11 and multiply to positive 10. So let's see. So x squared, what about minus 10x and minus 1x plus 10 equals 0? So minus 10x and minus 1, those will multiply to positive 10 and add to negative 11. So these first two terms are a group. I pull out the x that they have in common. I have an x minus 10 left over. These second two terms are a group. I'm going to pull out the negative 1 so that I have x minus 10 because I want my parentheses to be the same. And then my first term is coming from my parentheses that are in common. So x minus 10 is one factor. And then the other one comes from what's outside of the parentheses. So x minus 1 is the other factor. So if you set each of those equal to 0, x equals 10 or x equals 1. But of course, we want to check for reasonableness, right? Because we can't have any negative links. So since we have two answers, one of them might be extraneous. For example, if we plug in a 1 right there, that would be 3 times 1 minus 10. Is that positive or negative? Negative. So x equals 1 is an extraneous solution. So to find the length of RQ, we just want to do 3 times 10 minus 10, which would give us that the length of RQ is 20. All right, second topic of the day is what's called medians. So median is a special segment of a triangle, and what it does is it takes a vertex, like right here, and then it connects it to the midpoint of the opposite side. So takes a vertex, connects to the midpoint of opposite side, takes a vertex, connects it to the midpoint of the opposite side. So in this picture, that's why you have all these little tick marks, because it's saying, hey, this is the middle. So this is the middle, so these two sides are the same. This is the middle, so these two sides are the same. And what happens is the medians of a triangle will always cross at the same point in the triangle, and that point is called the centroid. And the centroid is actually the center of gravity of the triangle. So you might have, if you're taking like engineering at this, what am I spelling? If you're taking engineering at the CTE center, you might have heard of the centroid being the center of gravity, because that's an important principle to know. Like if you're building something, you have to know where the center of gravity is for your shape. So if you had a triangle, like on paper, for example, and you drew in the medians, which crossed at the centroid, if you put your finger right on the centroid, that's exactly like where you could balance the triangle on top of one finger, because that's where its center of gravity is. So that's kind of cool. So one other visual to show you real quick is in this triangle, it's going to draw the medians for us. So first it's just marking midpoints. So E is a midpoint, marking a midpoint right here. So we've got all the midpoints drawn. And now we're going to connect the opposite vertices to the midpoint. Connect vertex to midpoint, connect vertex to midpoint. And something that you might notice that it's doing now is that two of the small pieces are equaling one of the big piece. So if I show you that part again, if we're looking at how the medians are split up on either side of the centroid, it's like two small pieces make up one big piece together. And so that's something that we're going to be looking at a little bit more. So, for example, if we look at just this line right here, it's technically divided into like a small part, and then we have the centroid, and then it has a large part on the other side of the centroid. And so the median is split in a ratio of 2 to 1, where we have two of the smaller pieces equals one of the big piece. So what you could think about it is you could say like 2 of the small pieces equals one of the big piece, if that helps you better than just looking at a ratio, if that helps you understand it better. So, for example, in this triangle, we have all these markings. We have that CP is 20, so that's going to be inside the triangle distance. We have EP is 18, BF, ooh, that's a big one, is 39, and we're going to find the lengths of all these little things down below. All right, so we're looking for the length of PD first. Okay, so PD is right here. So PD is a small section, and we were given the big section, CP. So CP is 20. So what's going on is we've got this big section that's 20, then we run into the centroid, and we're looking for this smaller piece. Well, two smaller sections equal the bigger section put together, right? Also, I'm looking at your picture. Hang on. I'm wondering what this 30 is for real quick. I'm kind of thinking that CP was supposed to be 30. Change this guy to a 30. Sorry, I'm thinking about that while I'm talking to you. I think that was supposed to be a 30 in the picture. Okay, so we've got 30. Two small pieces equal one big piece. So we want half of that, which would give us 15, because 15, if that's right here, then we have two smaller 15s that add up to equal the 30 in the bigger piece. We can do the same thing for BP. So BP is right here. We know that the entire BF is 39. So remember, it's always split into like 3 pieces, right? Because we have that small piece, and then the bigger piece is like 2 more small pieces. So if the entire thing is 39, well, 39 divided by 3, that means that each section is 13. So BP, that's the bigger section, so that's 13 plus 13, or 26. So if we do one more together, then I'll let you try some. So PA, that's right here. We have that EP is 18. So PA, that's the larger section on the side of the centroid, and so that's going to be double the smaller section. So 18 times 2 would give you 36. All right, go ahead and pause the video, talk with your groups, work on those missing 3, unpause the video when you're ready to check your work. All right, so here are your solutions on this one. So FP is 13, CD is 45, and EA is 54. All right, another example in this picture, BD, CE, and FA are all medians, so those are the long segments. We know FG is x plus 8, and FA is 9x minus 6, so find x. All right, so the relationship between FG and FA is that FG is a small piece and FA is the whole thing. So we know it's split into 3 little sections, right? So if FG is x plus 8, that means we'll have another little x plus 8 and another little x plus 8, because the large section of the median is 2 of the smaller ones. So we can say 3 of the x plus 8 pieces equals 9x minus 6, because FA is also described by 9x minus 6. So 3 of the little pieces should equal the whole thing. So then we're just going to distribute. So 3x plus 24 equals 9x minus 6. So I've got 30 equals 6x, so x is 5. And last but not least, find the coordinates of the centroid of the triangle with these vertices. So we're just going to plot these vertices real quick. So plot 3, 1, that's right here. 6, 3, 1, 2, and 3, 5. All right, so I'm going to try and do this without a ruler since I'm just drawing on my screen. If you have some of these on your practice, you can grab a straight edge. It might make it a little bit easier to see where they all cross. But we're going to be connecting from the opposite side to the midpoint. So for example, if I've got this vertex, the opposite side is this one, and the midpoint of that is going to be right here. So I'm going to connect those two. For my next side, we could use the midpoint formula to figure out where the next midpoint is, but I'm just going to kind of estimate it based on like slope here. So from here to here is right 1, 2, 3, up 1, 2. So half of that would be right 1.5, up 1. So my next midpoint is right here. So I'm going to connect these guys. And then last but not least, I can already tell that they're crossing right there. So my next midpoint, same thing, is going to be kind of like up 1, right 1.5. So all 3 of my medians connect at the same spot, which is coordinate 4, 3. And so that is the centroid. All right, guys, so if you have any questions, and then I have some practice for you guys to do. I don't want you to do anything else today until you've finished your practice and checked it with a substitute. So go show it to her when you're done. She has the key. And then once you're completely done with your practice and have checked your practice with the substitute, then you can be done for the day. All right, guys, I'll see you next time.